I'm Shana versus Kanyo. In my part is, let's proceed on the classical problems of synchronization. First one is the bounded buffer problem. So, n buffers each can hold one item. Semaphore mutex initialized to the value 1. Semaphore full initialized to the value 0. And semaphore empty initialized to the value of n. So, bounded problem, ito po yung tinatawag natin na producer-consumer problem is, and it is one of the classic problems of the synchronization, which is in the problem statement is there is a buffer of n slots, with each slot is capable of storing 1 unit of data. There are one and two processes running, namely producers and consumer, which is this is the operating of the buffer. Let's proceed on the next problem, which is the readers-writers problem. So, a data set is shared among a number of concurrent processes. The readers only read the data set. They do not perform any updates. Next is the writers can both read and write. Next is problem. It is allowed also to multiple readers to read at the same time, and only one single writer can access the shared data at the same time. And the shared data, the datasets, semaphore mutex initialized to 1 that controls access to read count, and semaphore WRT initialized to 1 that which is the writer access, integer read count initialized to 0, how many processes are reading the object. This relates to an object such as a file that is shared between the multiple processes, which is some of these processes are readers and they only want to read the data from the object, and some of the processes are writers and they want also to write into the object. And so now let's proceed on the dining philosophers problem, which is the shared data, the bowl of rice, the data set, and semaphore chopsticks 5 initialized to 1. So this is the as you can see, this is the illustrations of the dining philosophers problem, which is the dining philosophers problem is example problem often to used in concurrent algorithm designed to illustrate synchronizations issues and techniques resolving the problems. So it was originally formulated in 1965 by Edskar as a student of the exercise presented in terms of computer and computing for access to the tape drive peripheral. And soon after, of course, Tony Howard gave the problem is present in the present form. Next is more problems with semaphore relies also too much on programmers not making mistakes and accidental or deliberated incorrect use of semaphore operations. As you can see, this is the signal wait, omitting of wait mutex and signal mutex are both. So the other problems of the semaphores is the in this slide. We will see the number of classical problems of synchronizations that as examples of a large class of concurrency control problems. And in our solutions to the problems, we use semaphores for the synchronization. Since this is a traditional way to present such solutions, however, actual implementations of these solutions could use the mutex locks in place of the binary semaphores, which is these problems are used to testing nearly every newly proposed synchronization scheme. Next is the monitors, which is the high-level abstractions that provides a convenient and effective mechanism for the process synchronizations, and only one process may be the active within the monitor at the time. So here the monitor is also the semaphores are used for the process of synchronizations, and it allows the process to access the shared data, which is monitor test down and monitor test set up into separate shells to the experiment with the semaphore. And as you can see in this slide, this is the schematic view of monitor. It having the entry queue, the shared data, the operations, and initializations code. This is the condition variables, condition x and y, which is the two operations on the condition variables is the x dot wait, and with the open parenthesis, which is a process that invokes the operation is suspended, and the x signal close and open parenthesis, which is resumes one of the processes if any that invoke the x that wait, which is these condition variables are user mode object, which is that cannot be shared across the processes, and it is enable threads to automatically release, lock, and enter the sleeping state. And lastly is, as you can see, this is the monitor with the condition variables. So here in the monitors and condition variables, the monitor is yung monitor is nagiging synchronization tool siya to design and to make a programmer's lives to be simple. And the monitor can be thought as a conceptualized box, which is here it consists a mutex lock object with condition variables, and that condition variable is basically a container of threads that are waiting on the certain conditions.